Most of us see a garbage truck for only a few seconds at a time. It rolls down the street early in the morning, pauses briefly, lifts a bin, and then moves on. By the time we're fully awake, it's already gone. The trash disappears, and so does the thought of what happens next. But that brief moment hides an entire system at work, a system built to handle everything we throw away, quietly, efficiently, and under far more pressure than most people realize. Because once your trash leaves the curb, it doesn't simply sit in the back of a truck until it reaches its destination. It's processed, compressed, monitored, and controlled almost constantly. So what actually happens inside a garbage truck? To understand that, it helps to start with a simple idea. A garbage truck isn't just a vehicle that carries waste from one place to another. It's a moving industrial machine designed to manage volume, weight, safety, and time all at once. Every part of it exists to solve a very specific problem. That problem is scale. Modern cities generate enormous amounts of waste every single day. If garbage trucks only collected trash without changing its shape or size, they would fill up almost immediately. Routes would take far longer to complete, fuel use would increase, more trucks would be needed, and streets would be louder, busier, and more congested. The solution to all of that pressure lives inside the truck itself. When trash first enters a garbage truck, it doesn't go straight into storage. It lands in an intake area known as the hopper. This is the temporary holding zone where bags, loose items, and bin contents collect for just a short moment before the machinery engages. Once the operator activates the system, hydraulic power takes over. A compaction mechanism begins to move, pushing the trash inward and upward into the main body of the truck. This isn't a gentle process. Hydraulics are capable of generating enormous force, far beyond human strength, and they repeat the same motion again and again throughout the route. Each cycle presses new material against what's already inside. Cardboard collapses almost instantly. Plastic containers buckle and fold. Wooden objects crack. Metal bends. Over time, everything is forced into a denser and denser mass, forming a tightly packed wall of waste. Inside the truck, nothing stays loose for long. Space is constantly being reclaimed. Different garbage trucks use different compaction designs. Some rely on large sliding panels that sweep trash forward in broad strokes. Others use rotating drums or screw-like mechanisms that pull material inward while crushing it. In some designs, a moving internal wall slowly shifts backward as the truck fills, maintaining balance and maximizing capacity. But regardless of the design, the goal is always the same: reduce volume without compromising safety or damaging the vehicle. As this process continues, the interior of the truck becomes a high-pressure environment. Trash isn't simply stacked, it's compressed into layers, held in place by steel walls, mechanical barriers, and constant force. The material inside is under stress, both physical and chemical. And that introduces a new set of challenges. Trash isn't dry or uniform. Food waste, liquids, and organic material begin breaking down almost immediately. As pressure increases, liquid is squeezed out, creating runoff that has to be managed carefully. Without control, this would leak onto streets and corrode the truck from the inside out. That's why garbage trucks are built with internal drainage systems. Channels guide liquid towards sealed collection points. Interior surfaces are coated with materials designed to resist corrosion from acidic waste. Doors and seams are engineered to contain odors and fluids even under pressure. Even with all of this protection, the inside of a garbage truck is a harsh environment. Heat builds up, gases form, sharp objects shift, and occasionally something enters the system that never should have. This is where modern garbage trucks reveal just how advanced they've become. Many newer trucks are equipped with internal cameras that allow operators to see directly into the hopper and compaction chamber. These cameras aren't for convenience, they're for safety. Items like lithium batteries, pressurized containers, or certain electronics can spark fires or explode when crushed. Detecting them early can prevent serious damage or injury. Sensors also play a critical role. Pressure sensors monitor how full the truck is becoming, warning the operator before safe limits are reached. Resistance sensors detect when the compactor encounters something abnormal, like an object too dense or too large to process safely. All of this information feeds back to the operator in real time. Safety matters because garbage trucks are among the most dangerous vehicles operating in everyday environments. The machinery involved is powerful enough to destroy furniture and metal, and it doesn't slow down unless it's told to. Combined with frequent stops, blind spots, and public streets, the risks are significant. To reduce those risks, garbage trucks are built with multiple layers of protection. Many compaction systems require continuous input from the operator. If a control is released, the machinery immediately stops. Emergency shutoff buttons are placed both inside the cab and near the hopper. Backup cameras, warning alarms, and proximity sensors help drivers detect pedestrians, cyclists, or obstacles. In some cities, trucks even include automatic fire suppression systems. If heat or smoke is detected inside the waste compartment, the system activates instantly, flooding the area before flames can spread. All of this happens quietly, often unnoticed, as the truck continues its route. Eventually, the truck reaches capacity. At that point, it's no longer efficient or safe to keep collecting trash. The route pauses, and the truck heads to the next stage of the process. This is where the rear of the truck finally opens. At a transfer station or disposal facility, the truck positions itself over a designated unloading area. Hydraulic locks release, and the rear door swings open. Then, an internal ejector panel pushes the entire compressed load outward in one smooth motion. What comes out isn't loose garbage. It's a dense, rectangular mass shaped by hours of pressure and mechanical movement. Facility workers inspect it, sometimes removing items that don't belong. From there, the waste is redirected based on local infrastructure. Some of it is sent to landfills, where it's buried and sealed in carefully managed layers. Some is sent to recycling centers, where machines and workers separate materials by type. In other cases, waste becomes fuel, burned in controlled facilities to generate energy. The garbage truck itself doesn't decide where anything goes. Its job is more specific than that. It collects, compresses, and delivers waste in a form that allows the rest of the system to function efficiently. That's why garbage trucks come in so many designs. Narrow residential streets require different machinery than industrial zones. Some cities use trucks divided into separate compartments, so recycling and general waste never mix. Others rely on automated arms that reduce the need for human lifting altogether. But no matter the shape or size, the principle inside remains the same. Control volume, maintain safety, keep moving. Seen this way, a garbage truck isn't just cleaning up after us. It's acting as a pressure valve for modern life. Without it, waste would accumulate faster than cities could manage. Streets would clog, health risks would rise, systems we rely on would begin to strain. So the next time you hear a garbage truck outside your window, consider what's happening beyond the sound. Inside that metal shell, trash is being reshaped, compressed, monitored, and prepared for the next stage of its journey. Not magically, not effortlessly, but through careful design, constant force, and a system built to work quietly so the rest of the world doesn't have to. Thank you for watching. If there's another everyday system you'd like to understand more deeply, let us know in the comments. And if you enjoy learning about the hidden machinery behind daily life, consider liking the video and subscribing to the channel.